Hey guys, so this video is first in the series that I'm going to, publish in the future. This video is all about CI/CD pipelines, and it's also related to the document I shared in the community for day two, and about the commit strategies as well. You know, we need to know what's the reason behind those branches, what's the reason behind those commits, right? So after knowing how important it is to branch, how important it is to, do the proper commit in a proper manner, right? So that's very important for a developer profile to help you stand out in from from the crowd. So I'm going to tell you how things are done in production. How typically your server deploys with the help of the branches that you create, how it is tested, and the complete flow. So there might be some, you know, topics or subjects that you don't know. You can search them on your own. I will try to give you a brief in the video about those particular topics, but I will not go into deep. Some of the topics you might already be knowing, but I need to brush it up if you are, forgetting those, because those are important, especially the software development life cycle. It is very important. Not every part of it, but some of the testing part are always used, right? So let's jump into the flow that we have here. So a typical developer flow looks like this. So developer creates a branch. Branch is can be any feature branch. It can be a bug branch, bug fix branch, right? Then you write and commit the code, and that code goes through the remote. Remote is GitHub. It can be Bitbucket. It can be GitLab. It can also be a self-hosted one. When the privacy is of utmost importance, right? We need to keep it away from the public internet. We don't want industries to train their AI models on our code. Then we just create our own self-hosted Git server. So that's how things are done. Then this CI/CD pipeline is triggered. Triggering happens on multiple events. Event is very important. Event can be a push event, it can be a commit event, it can be a pull request. If you don't know about pull request, you should go and search it on the internet, right? So each of these emit an event. So there are other events as well. You can look into Git or GitHub for the event. Mostly it's on the cloud. For Git, there are also events, but for CI/CD pipeline, we generally use the GitHub events or Bitbucket events, or whatever provider you are using. They have their own set of events. Then we build the code. Package all the dependencies of your code into a single package, and then we do the linting process. Linting is like checking which of the packages or which of the modules in your code are not properly intended, right? We do the linting process. Then code quality is checked. How well you have written the code, how well you have named your variables, how well you have named your functions, classes, and things like that. In Python there is like there are multiple level of code quality checks. You need to know about those if you are using Python. Then we perform unit test. Individual functions are tested, right? In unit test, and then we do the code coverage test. Code coverage is like, if 40% of my test pass, I will just go ahead. If they fail, I will not go ahead. It's something like that. You can also do a bit of research on this on your own. And then if all the checks pass, we just notify the developers that all the checks pass, or if not, then also notify the developer. But when it fails, it's most important, so that's why I mentioned it here. And if it fails, you go through all the processes, all the stages of the flow all over again. And if it is passing, we create a PR, we do the code review, your team reviews the code, and it is approved. If it is not approved, we go through all the stages all over again that I mentioned above. Then we just merge the target branch, and then again the CI pipeline is triggered. This time we do it at the integration level, right? Front end, back end integration. Multiple backend services are integrated, database is integrated, and things like that. And we test it all in a complete package, with the UI, with the all the services running for the end use case. Then we have security scanning. Security scanning is like finding out critical vulnerabilities in your code base that might lead to exposure of credentials or remote hijacking or attacks. So these kind of scans also happen. It's also automated these days using AI agents, and Copilot also does it, and there is CodeRabbit and multiple other platforms are there apart from these two that do the code scanning. Then we have create Docker image stage. This is not always important, but many companies use Docker these days, so I've just mentioned it here. You need to know about Docker. It's a very essential concept that needs to be practiced well, because it's used in the industry these days, and even the freshers are expected to know Docker these days. So Docker image is nothing but your operating system plus your software, and it's all dependencies packaged together, so that whenever we want to run it, we can run it anywhere on any machine. That's how flexible things are with the Docker. Otherwise, you have to install the OS, then you install the packages, and things become complicated. So Docker simplifies that particular stage of the deployment. Then artifacts are there. Artifacts come into play when we have a build output, for example exe file in the Windows, or APK in the Android, or DEB file in the Linux environment. Artifacts are executables most of the time, or sometimes these are the files that are generated. You cannot be always working on a project that requires server to be deployed, right? Sometimes you might be working on an application, Android application, or sometimes you might be working on a particular open source project that does not need a deployment, right? Then you use artifacts. So for example, if you are working on an Android application, right, artifacts generate APK files, right? And then those are saved, and then further we just publish those using automated scripts on Play Store, and then it goes to the public, and then the user installs it. So in that particular scenario, artifacts are used. You can use GitHub artifacts, for example, when you run GitHub actions. Then we have checks again, if all the checks are passing or not, and then we notify the team again if it is failing, and if it is passing, we just go ahead and deploy it. Smoke testing is done, staging is deployed, end-to-end test again is done, performance test, how well it is performing under load, like from 100,000 million or billions of users. So those are tested. Every company does it. Your performance testing is very important. User acceptance testing is not always done, but sometimes when there is a client involved in the production deployment, they need to test it before it goes to the client, right? From client, I mean the users. Suppose you are working for a company, and then the company is working for a client, and then client wants to test whether this feature is up to its requirements. So then they do the test on their own, like testing all the feature and saying, then they tell you that okay, this is fine, you can go ahead and deploy it in the production. Then you go and ready for the production, and then you deploy it, right? Sometimes it is not a automated deployment. For mission critical, we do the manual approval, right? Suppose you are deploying some code on the firmware of Mars orbiter mission. What will happen if auto deploy fails, right? We don't want to take that kind of dangerous approach for that kind of critical mission, right? In that particular scenario, we do the manual approval, right? I'm just taking an example. It might be possible that they're not doing this, but I'm just telling you through an example. Then there's deployment to production. There's blue, green, and canary as well. You can do a search on your own. This is a very advanced concept. I don't want to tell in this particular video. And then there's monitoring, logging, Prometheus, Grafana. These two are very famous for monitoring and logging. So monitoring and logging is like how you do typically in terminals, right? System, you open VS Code and then run the projects, or open a terminal and run the projects on your local system, right? But that's not how things are done in production. You can't watch millions of users and the logs that they produce. So you do that in the production using with use of Grafana. So they both are used to create dashboards that are specifically for monitoring and logging. And especially in production, you can't log the user details in your system, on the server. That comes under GDPR, and there are multiple compliances that you need to follow. So you can't really log the personal identification things in the logs. So you just also need to be aware of that as well. Then there is health check that needs to be performed. Database is working fine, my backend services are working, then great. So all those things are tested here, and then we do the again a final check. Issues are detected now, then that's great. We deploy everything, and then again we are tracking multiple things, right? Error rate, latency, right? How much time it is taking to respond, how much errors are happening. Suppose like there are millions of users and they are hitting a particular SQL queries on the backend for search, right? Google must have some kind of error rate implementation which they can track, right? And they can use that to improve the user experience for searches, right? So that's how you monitor, like for particular percentage of users, how much percentage of queries are failing, right? So that's how things are tracked on the backend, on the production or the enterprise level, right? So things are really complicated. You need to know about each step. If you know these steps, you are way ahead of others, right? I was not aware of these things when I started working. I just became aware when I saw the actual production environment. And then if it is automated, all this test all the fails, some of the test fails, what happens is like you need to do an automated rollback uses your commit to roll back. For example, if you're committing a particular feature and it causes production to go down, server stops working, then you need to instantly go to the last commit, right? That's why your commits are very important. It should be atomic, one feature at a time. That's why there should be feature specific branches, feature specific commits, so that you can just manually or automatically roll back, right? Then when you roll back, you just go through all the steps all over again to implement that feature. So it's a very long process, not complicated, but you need to be aware of some things. Otherwise, it's an easy to understand concept. I hope you all understood this one and now understood the importance of branching and committing strategies. I hope this video helps, and see you in the next video. Thank you.